video we are going to talk about our Leetcode problem of the day, and our problem is minimum number of pushes to type word to. Basically, you have been given a string word containing lowercase English letters. Okay, telephone keypads have keys mapped with distinct collections of lowercase English letters, which can be used to form words by pushing them. For example, keypad 2 is mapped with A, B, C. We need to push the key one time to type A. Let me explain the question over here. We have been given the strings over here like A, B, C, D, E, F or A. Okay, means the strings you have been given over here, and what you have to do, you have to means return the minimum number of pushes needed to type word after mapping the keys. Basically, this is the keypad 1 2 3 4 5 6 7 8 9. Okay, so basically the keypad 2 is for A, B, C. This is for D, E, F, G, H, I, J, K, L, M, N, O. Okay. Then P, Q, R, S, P, Q, R, S. Then T, U, V, W, X, Y, Z. Okay. So basically these strings are allocated to each and every keypad of the mobile. Okay. So basically what we have to do, we have to return the minimum number of pushes. Means let's take a more bigger example like 2, and it have values A, B and C. It have values of A, B, C. Okay, so basically we have been given string of what? String of A, B, A, C, A, B, C. Okay, so basically this string you have been given. So what you have to do, basically the string in mobiles, the keypad mobiles, what system was there? If you want a first number, you have to have one push. If you want second number, you have to do 2 times push the keypad. If you want third number, you have to push 3 times the keypad. So in this way the olden times of phones were functioning. So now let's see, our first letter is what? A over here. So basically for A there is only one push, so okay, one. Then for B we have to do 2 times pushes, okay, 2. Then A, again one time push. Then C, we have to push the keypad 3 times. Then again A, one time. Then B, 2 times, okay, and then C, 3 times. So what is the total number of pushes we have to do is 1 plus 2 3, 3 plus 1 4, 4 plus 3 7, 7 plus 3 10, 13. Okay, our answer is what? 13. Means we have to push the keypad 13 times to get this exact string over here. Okay, so basically we have to return the minimum number of pushes needed to type the word after remapping the keys. Means we have to map the keys over here. Let me explain. Basically you have to use counter variable over here. So if you have not watched my previous video, means yesterday's problem of the day, so please watch it. It's basically on the use of counter and the items of functioning of the counter variable to find the indexes, its frequencies. Okay, we can say. So now let's begin. Basically our first example is what? ABC, DE, ABC, DE. This is our first example. So what we have to do, we have to allocate this string uh, in the keypad over here. Okay, so basically this is our keypad. We keep in mind we have to start from 2 to 9. Okay, this you are able to see. We have to start from 2 to 9 to each distinct collection of letters. Okay, so basically this is 2 3 4 5 6 7 8 and 9. Okay, so basically we will use counter over here. Counter means what it will do? Counter variable means it will give us the frequency. A is present one time, B is present one time, C is present one time, D is also present one time, and E is also present how many times? One time. So this kinds of frequency it gives us. So basically all are present one time over here, so we'll allocate it. This will be A, B, C, D, E. Okay, basically we have done with it. So in this case, all are able to push how many times? One times. Okay, means uh, total means A is pushed one time, then B is pushed one time, then C, D, and E. Okay, so basically we have to, our minimum pushes are what? 5 over here. Same case, take the same case. For example, if you put A, B, C, means allocate A, B, C in adjacent ways, 4, 5, 6, 7, 8, and 9. Okay, so what you will do means if you allocate it like A, B, C, then D, E, and F. Oh, sorry, D and E. Okay, so basically you have allocated over here. So what you will do in this case means what I am trying to say over here, you have allocated A, B, and C to 2, and D and E in 3. So basically this position is 1 push, this position means this string is get on 2 push, and this string is get on 3 push. Okay, similarly this on 1 push and this on 2 push. So basically for getting the string A, B, C, D, E, how many times we have to push is 1 plus, for B 2 times push, for C 3 times push, for D 1 time push, and for E 2 times push. So basically what our answer will be, 3 plus 3 6, 6 plus 3 9. Okay, so basically we have to push 9 times over here. Okay, but while allocating the strings only, in the adjacent distinct times in the distinct positions, so we have got our total kinds of pushes 5. In this case we have got 9 as our answer. Basically you have to return what? Minimum. Please read the question over here. Return the minimum number of pushes to type the word after remapping the keys. Okay, so in this way we have to function. So let's understand with the help of another example also. Basically I've been given xyz xyz xyz. Okay, basically I've been given xyz over here. So this is 2 3 4 5 6 7 8 and 9. Okay, so basically here our first string is what? xyz. Okay, this is x, then y. First of all, let me explain you use of counter over here. You will use a counter of word, means we will find this counter of what? Word over here. Okay, so basically we will find counter over here. So it will gives us the occurrence of x, y, and z. Okay, basically x is present how many times? 1 2 3 and 4. X is present 4 times. Basically I am considering this example, this one. X is present how many times? 1 2 3 and 4 times. Y is present 1 2 3 and 4 times, and basically Z is also present 4 times. So we have got 444 frequency of our strings. So now we will allocate it. First string will be what? It will be X, then Y, and then Z. Okay, so we have got it over here. Now let's find the number of pushes. X will be pushed only one time, but how many X are given? X are given 4, means 1. X will be pushed for one time only, so 1 plus 1 plus 1 plus 1 for 4x. Okay, then y will be pushed also one time. This is basically for x, and this is for y, 1 plus 1 plus 1 plus 1. Sorry, this is for y over here. Okay, and then plus 1 plus 1 plus 1 plus 1. This is for what? Z over here. So basically our total will be what? 12. So we have to do 12 pushes over here. Okay, in this case. Now let's move on to our next example, which is a bit difficult example, but it's means can't say difficult, it is a tricky example. So now let's begin over here. Okay, basically our string is what? A A B B C C D D E E F F G G H H and 6 times I over here. Okay, so now let's begin. In this string first of all we will find the counter over here. Counter of what? Counter of word. Okay, word is given string over here. Counter of word we are going to do. So basically the count, how the counter works, it gives the frequency of variable which comes first, means which has the highest frequency, it gives that string first over there. So we see I is present 6 times. Okay, then A is present 2 times, B is present 2 times, C is present 2 times, D is present 2 times, E is present 2 times, F is present 2 times, then G is present 2 times, and H is also present 2 times. Okay, so basically now let's allocate the strings over here in the keypad. 2, 3, 4, 5, 6, 7, 8 and 9. So basically our first string is what? I over here. So we will start in the chronological order, means first this, then this, then this. Okay, so basically let's begin. First we will place our I over here. Okay, then A, then B, then C, then D, then E, F and G. Okay, we have completed with G. Then again start putting with H. Okay, similarly if there will be H, what we can say, J, K. Okay, present one time, present one time, so it will be like H, J, K. In this type it will be, no sorry, it will be H, J and K, like this over here. Okay, so this was the total explanation. Now let's find out the frequency over here. Basically what kinds of frequency we are given for this case. It is 6 6 1 2 3 4 5, again 2 and again 2. Basically these are the respective frequencies of the given. This is for I, A, B, C, D, E, F, G and H. Okay, the respective frequencies are given over here. So basically what we have to do, we have to go for indexes over here. This is 0 index, 1 2 3 4 5 6 7 and 8. This is the basic indexing we have been given over here. So after applying these indexes, we have to use one simple formula over here, means how many strings can come till last over here, till G over here. Maximum strings can come, means till 0 to 7 over here. So we will divide it by 8 over here. Okay, means this next string is what? This will start with another position, means in the beside position with push to position. So we'll do our I is basically this indexes, and I divided by 8 plus 1. Okay, so for example our I is 0, so 0 by 8 plus 1, it will be 1 push. 0th position is 6 over here, means for I it will be 1 push. For example our indexes is 8, then 8 by 8 plus 1 is 2 over here, means we have to push 2 times this 8 position, we have to push 2 times the edge to get edge in this. Okay, so basically this was the means total explanation. Now let's begin with the coding approach over here. Okay, first of all we will create a simple counter over here. Let me explain you by the running of the code. First of all we will create a counter over here. Let me show you how the counter works. Let me return A. Let me run it. A is what? Counter of word. Basically this is the counter. A is present one time, B is present one time, C is present one time, D is and E is also present one times. Okay, let me use this example. Okay, now let's try to run it. Okay, so basically this is the performance of the counter, means we get this is our basically A over here. Okay, as you are able to see, the frequencies over here we have got. Okay, in this case, so now we have applied the counter over here. Then we will create a simple list and the count variable. Our list, okay, this is basically our list over here. Then we will create a count. Basically it will count the number of pushes over here. Okay, then for then we will run a for loop, means iterating through each element of the what each element of the counter variable, means A, for I comma j in what A dot items. Basically I have discussed about it in the previous video, so you can see it. Okay, so we will append it in the list. R dot append what R dot append j. Let me return R over here. Let me show you how it will look. This is after returning the R. Okay, so basically this is basically the frequencies of what from A to I over here. Okay, so I have written the R over here, means now our R is looking like this. So basically we have to sort it. First of all we will sort it, then we will reverse it. Okay, means the small values will come at the last and the large values will come at the first. Then R dot reverse. Okay, now let's return our R. Now let's try to return our R. Now as you are able to see, we have got it. So in the solution also, as you are able to see that we have got our means expected string of means list over here of the frequencies. Now let's move forward. Let's run a for loop over here for k in range. For k in range, what length of our R, means it will run till the length of our till the end of our R over here. Okay, so for k in range length over R, length of our R, let's initialize b as what, b as the index divided by index of the given string in the means frequency in the R divided by what 8 over here. Okay, divided by 8 and plus 1, this gives the number of pushes. Number of what push, number of push. Okay, basically this is the formula for number of push. Now now our now we will increment our count will be incremented by what, by multiplying each push with the frequency of the means frequency of the each string. Number of push multiplied by R of k. Okay, now we have multiplied it which each frequency. Now let's return our answer. Return what, return our count. So now let's try to run it. Yeah, it's passing all the test cases over here. So now let's try to submit the code. Yeah, it's being accepted over here. So this was the Python solution for our question, basic question over here. Okay, and this was the basically example. Now let's try to solve it with the help of C++. Okay, so in C++, the syntax of the C++ code will be different, but the logic will be same only. Let me reset it one time for you. Okay, basically we have created a means we have been given, let me add std over here. Okay, so we have added std. Okay, so now let's begin. We will first of all we'll create an unordered map over here of int means character with int frequency. Okay, std of what? Unordered map, unordered map over here of what? Of character with string, or sorry, character with int, character with int. Okay, now let's initialize it as frequency. Okay, let's say frequency. We have created an unordered map of frequency over here. Then for each character in the word, for each character in the word, for char ch in word. Okay, for char ch in word, our frequency of ch will be incremented. Means for each word in the word, means for each character in the word, our frequency will be incremented over here. Means we will basically put the frequency, means append the frequency in the uh, uh, basic unordered map over here. Then we will create a vector over here, vector of int means count over here, std of vector of what? Int over here, basically int, and let's name it as a counts over here. Okay, so for each pair in the frequency, for each pair in the frequency, okay, we will append the means append the second values. Okay, append the second values in the counts pair over here. Okay, so constant and auto ampersand pair for each pair in what frequency. Okay, the counts dot pushback pair dot second, counts dot pushback pair dot second. Okay, now we will first now we will sort the counts means a map over here. Okay, so std sort, basically you can see the C++ and the Python code, means compare both the codes over here. Both the codes are same, only just difference is of some syntaxes and nothing else. From counts.begin to counts.end. Okay, and let's reverse it, means let's make it in decreasing order. Std of greater int of empty map. Yes, okay, we have created it. Okay, and done the sorting procedure over here. Then let's initialize int c equals to 0. Okay, so for int k equals to 0, means from 0 to counts dot size, means the size of the counts. Okay, over here we will apply the given condition, that formula. Okay, b is equals to what? K by 8 plus 1. So for int k equals to what? Initialize to 0, k less than what? Counts dot size, k less than counts dot size, and increment our k. Okay, now we will initialize int number of push, the formula over here. The formula is what? K by 8, k by 8 plus 1. Okay, this is the basically number of push over here. And then we will increment our then at last we will increment our what? The count variable, means c. C plus equals to number of push over here, number of push multiply what, multiply counts of k, means frequency of each frequency in the counts variable over here. Then at last we will just return our C, return C. Okay, so now let's run the code. It's giving some runtime error. Int C equals to 0. We have not put the semicolon over here. Now it's good. Yeah, it's running all the test cases. Now let's try to submit it. So basically our C++ code is also being accepted. So this was all for our today's problem of the day. So thank you friends.